Hello students, we are learning the very beautiful chapter wave optics. Just we have learned about the principle of superposition of the waves, right? How to get the dark region and how to get the bright region. Now we will discuss about the interference, and before discussing that, let us know what are the conditions about the path difference and phase difference for interference pattern. So let's start. So my dear student, this is about the condition of the path difference for interference. Consider a wave traveling in the positive direction of the x-axis. So this is x-axis, this is y-axis. The wave, this is the plane of vibration is along y-axis and the wave is traveling along x-axis. So name these points. Say A, B, C, D, E. Now let us see the path differences from 0 to B. That is for this complete wave. The path length is how much is equal to wavelength, and that is equal to lambda. So half of that is lambda by 2. So distance between origin O and the point A is half of the wavelength, and that is how much? Lambda by 2. Then from A to B it is again lambda by 2. But we can say from O to B it is 2 lambda by 2. Then from O to C it is 3 lambda by 2. Then from O to D it is 4 lambda by 2. And from O to E it is 5 lambda by 2. So my dear students, what you understand here? That is for this complete wave, the path length is equal to wavelength. That is how much? That is lambda. Okay, so the wave consists of the one crest and one trough. So half of that, so lambda by 2. So O to A is a lambda by 2 distance. O to B is a 2 lambda by 2. Then O to C is a 3 lambda by 2. O to D is a 4 lambda by 2, and O to E is a 5 lambda by 2. Okay. Now let us analyze the same diagram thrice from the point of view of interference. आता आपण हाच डायग्राम 3 वेळा बघणार आहे. कशासाठी? इंटरफेरन्स स्टडी करण्यासाठी. इंटरफेरन्स म्हणजे काय? When two or more waves reach simultaneously at a particular point, right? So crest upon crest or crest cross with the trough. So let us see what situation happens, whether there is a destructive interference or constructive interference, whether there is a bright point or whether there is a dark point. We have to think about that. So here again we are considering the wave pattern, same wave pattern here. Okay. So again from 0 to A it is lambda by 2, 0 to B 2 lambda by 2, 0 to C 3 lambda by 2, 0 to D 4 lambda by 2, and 0 to E 5 lambda by 2. So here the same pattern considered 3 times, right? So now we have another wave starting from point O. आता एकच pattern आहे, तो इथं 3 वेळा घेतला. And after that we are considering one more wave. This is a red colored wave. It is starting from the point O. Its wavelength is also same. Its wavelength is also same. Its frequency is also same. But what is the difference is that its amplitude is not same. म्हणजे पहिल्या वेव्ह जे आहे तिचा amplitude बघा आणि हा दुसऱ्या वेव्हचा amplitude बघा, हा सेम नाहीये. ओके. Okay, the amplitude is not same. So slightly different amplitude is there. But what we observe is that for this wave, blue colored wave, and for this red colored wave, or you can say for the first wave and for the second wave, the crest coincide with the crest, and here the path difference is 0. Why path difference is 0? Because first wave is started from the origin, second wave is also started from the origin. And again, what happens at point B? The first wave completed its first wave. The second wave also traveled its first wave. That is the total distance between O to B is a lambda for the first wave as well as lambda for the second wave also. So automatically the path difference is 0 here. Now when the path difference is 0, definitely what happens here? Crest matches with the crest, crest overlaps with the crest, crest coincide with the crest, trough coincide with the trough. So what is going to happen is that these displacement, that these amplitudes are going to be added. So amplitude of the first wave is A1, amplitude of the second wave is A2. So these two will be added. So it will be A1 plus A2, and the resultant amplitude will be A1 plus A2. Yes, and there is a constructive interference. When there is addition of the displacement, then we say the constructive interference. So here constructive interference takes place. Okay. Now let us consider here another wave. Okay, in this pattern. Now see again here crest matches with the crest and trough matches with the trough. But what happens is that the first wave, that is the blue wave, has started from the point O and the red wave has started from the point B. Means the blue wave and the difference between the blue wave and the red wave is how much? It is 2 lambda by 2, that is lambda. So if we have another wave starting from the point B, then the path difference is how much? Lambda, that is of one wavelength. See here how much is the path difference? In the first diagram it is 0 wavelength. Here it is 1 wavelength, but still we are getting the constructive interference. Crest matches with the crest, trough matches with the trough. Yes, that is coincides. Crest coincides with the crest, trough coincides with the trough. So amplitudes get added. So there we are getting the constructive interference. Now see here, yes, in the same diagram, that is the crest coincide with the crest and constructive interference takes place. Now in the third diagram, if we start the red wave from the point D, again what we have observed here is that crest matches with the crest, trough matches with the trough, constructive interference occurs here. But this red wave has started from the point D. Means what is the distance between this? What is the path difference between the first wave and second wave? It is 4 lambda by 2. That is equal to 2 lambda. Okay. So here is also constructive interference, crest inside with the crest. What we observe here is that in the first diagram, the path difference is 0 lambda. There is a constructive interference. In the second diagram, there is a path difference 1 lambda. There is constructive interference. In the third diagram, there is a path difference 2 lambda. There is a constructive interference. Means to have a constructive interference, the path difference may be 0 lambda, 1 lambda, or 2 lambda, and so on. This is our conclusion. See, in the first case, the path difference is 0. In the second case, the path difference is 2 lambda by 2, that is equal to lambda. In the third case, the path difference is 4 lambda by 2, that is equal to 2 lambda. Okay, so 0 lambda in the first case, 1 lambda into the second case, and 2 lambda in the third case. So if we observe this 0 to 4, these are the even numbers, right? And they are multiple of what? Half of the wavelength. So thus, when the path difference is n into lambda by 2, such that this n is a even number, when n is an even multiple, yes, that is 0, 2, 4, 6, when n is the even multiple of the half of the wavelength, we get constructive interference. We get constructive interference. Understand? Or when the path difference is n lambda, but the value of n is what? 0, 1, 2, 3, like that, where n is equal to 0, 1, 2, 3, then also we get constructive interference. म्हणजे constructive interference आपल्याला कधी मिळतो? जेव्हा path difference हा काय असतो? Even multiple of half of the wavelength असतो किंवा integral multiple of the wavelength असतो. Okay. Now let us consider the conditions for path difference for destructive interference. आता destructive interference होण्यासाठी काय कंडिशन्स असतील? तर पुन्हा इथं बघा, ही एक वेव्ह आहे, इट इज ट्रॅव्हलिंग अलोंग द एक्स ऍक्सिस. ओके, सिमिलरली देयर आर सम पॉइंट्स A, B, C, D, like that. Point A is at 1 lambda by 2, point B is at 2 lambda by 2, point C is at 3 lambda by 2, point D is at 4 lambda by 2, and point 5 E is at 5 lambda by 2. Same thing that we have discussed just now. Yes. Now let us analyze the same design 3 times. Same design, let us analyze 3 times. So this is first time, second time, and third time. Now what we have to do? We have to consider the another wave, red colored wave. Remember? Okay. In the first case, what we have learned previously, what we have learned? We have learned the constructive interference. Now we are learning the destructive interference. Now in constructive interference, what we observe is that crest matches with the crest. In destructive interference, the crest will match with the trough. So see here, if we have another wave, okay, it will start from the point A. But what happens here is that for this first wave, that is blue wave, there is a trough, and for the second wave, that is red wave, there is a crest. So crest matches with the trough. As the crest matches with the trough, there is a destructive interference. So crest coincides with the trough, and what is the path difference? C. The red wave started from this point A, and the blue wave started from point 0, and the path difference is how much? Lambda by 2. So here is the destructive interference takes place. Now, if we have another wave starting from the point C, now see, this is the point C, and the wave started from here. So what we get is a lambda by 2, lambda by 2, lambda by 2. So the path difference is how much? 3 lambda by 2, 3 lambda by 2. Again, here the crest matches with the trough, there is a destructive interference. So crest matches or crest coincide with the trough, so there is a destructive interference. Now let us start the wave from the point E. Then what you understand is that the distance, that is the path difference between the two waves is what? 5 lambda by 2. So here the path difference is 5 lambda by 2. The crest matches with the trough. So from these three cases, what you understand is that when the path difference is lambda by 2 or 3 lambda by 2 or 5 lambda by 2 and the crest matches with the trough, we get the destructive interference. Yes? Yes. So together we are going to conclude it. In the case 1, the path difference is lambda by 2, that is 1 into lambda by 2. In the second case, the path difference is 3 into lambda by 2. And in the third case, the path difference is 5 into lambda by 2. So what you understand here, this is the lambda by 2, lambda by 2, lambda by 2. This is 1, 3 and 5. Means what happens here? For the destructive interference, 1, 3 and 5 are the odd numbers, and this is half, lambda by 2 is half of the wavelength. Means here the path difference, if the path difference is odd integral multiple of half of the wavelength, if the path difference is odd integral multiple of half of the wavelength, we will get destructive interference. 1, 3, 5, these are the odd numbers. So we can conclude that for the path difference n into lambda by 2, where n is equal to 1, 3, 5, 7 and so on, we have the destructive interference. Or when the path difference is 2m minus 1 into lambda by 2. So what is this 2m minus 1? This is the definition for odd numbers, right? So m is equal to 1, 2, 3. So obviously, if you say 2 into 1 is 2, 2 minus 1 is 1. So what you get is 1. So this is for just to indicate. This is to indicate the odd number. 2m minus 1 is taken. So we get the destructive interference. Now, what we have learned about is the path difference. Now, let us consider about the phase difference. Path difference means difference in length, and phase difference means difference in angle. So actually, it is very simple. ज्या कंडिशन्स तुम्ही आता पाथ डिफरन्स साठी काढलेले आहेत त्याच्यामध्ये फक्त लॅम्बडाच्या जागी 2 पाय टाकायचं. लॅम्बडा जिथं आहे तिथं 2 पाय टाकले की तुम्हाला फेज डिफरन्स मिळून जातो. इतकं सोपं आहे. Let us see what to do here. Consider a wave traveling in the positive direction of the x-axis. Now let us know now name the points. जसं मगाशी केलं तसंच इथे पॉइंट्स ना नेम देऊया A B C D E. बरोबर आहे. आता फेज डिफरन्स बिटवीन 0 to pi, 0 to पॉइंट A इज अ पाय. इथपर्यंत किती पाय आहे त्याला आपण 1 पाय म्हणू. त्यानंतर B पर्यंत किती होईल 2 पाय, C पर्यंत 3 पाय, D पर्यंत 4 पाय आणि E पर्यंत 5 पाय. ऍक्च्युअली मगाशीच मी तुम्हाला सांगितलं की लॅम्बडा इज इक्वल टू 2 पाय असतं. तर पाय इज इक्वल टू लॅम्बडा बाय 2 असतं. मगाशी आपण इथे काय घेतलं होतं लॅम्बडा बाय 2, 2 लॅम्बडा बाय 2, 3 लॅम्बडा बाय 2, 4 लॅम्बडा बाय 2, 5 लॅम्बडा बाय 2. फक्त लॅम्बडा आला की पाथ शब्द वापरायचा, पाथ डिफरन्स, आणि अँगल आला, पाय आला, अँग्युलर डिफरन्स आला की पाय येतो आणि तिथे तुम्हाला फेज हा शब्द वापरायचा आहे. So let us analyze the same diagram 3 times. जसं मगाशी केलं तसं हीच डायग्राम आपण आता 3 वेळा कन्सिडर करूया. केली कन्सिडर. आता पुढे काय करायचं, या सेकंड वेव्ह घ्यायची. If we consider another wave starting from the point O, now this is the wave again starting from the point O, means the phase difference or you can say the path difference is 0 or a phase difference is 0. Yes, yes, crest matches with the crest, trough matches with the trough. So there happens the constructive interference. Crest coincide with the crest and the phase difference is 0 and there is a constructive interference takes place. Now if we have another wave starting from the point B, आता आपण दुसरी एक अजून एक वेव्ह घेतली ती पॉइंट बी पासून स्टार्ट होत आहे. मग आता त्यावेळेला तुम्हाला हे OB इतका जो फेज डिफरन्स आहे तो किती आहे 2 पाय आहे. फेज डिफरन्स किती आहे 2 पाय आहे, म्हणजे परत तुम्हाला काय मिळालेलं आहे इथं कन्स्ट्रक्टिव्ह इंटरफरन्स मिळालेला आहे, and crest coincide with the crest and trough coincides with the trough. So we get the constructive interference. Yes. Now in the third diagram, the second wave starts from the point D. But what we observe is that the phase difference, that is angular difference, is about what? 4 pi. 4 pi. Yes. Here is also constructive interference because crest coincides with the crest. Now, my dear students, if you observe the case 1, what you observe is that the phase difference is 0. Okay. In the second case, the phase difference is 2 pi. And in the third case, the phase difference is 4 pi. So it is a 0 pi, then 2 pi and 4 pi. So what I observe is that just this pi is multiplied by what? Even numbers. So together you can say there is an even multiple. So when the phase difference is n into pi, and this n value is a 0, 2, 4, 6, that is even multiple. Even multiple, we will get the constructive interference. We will get the constructive interference. Now, let us discuss. See, the title is changed here. Consider the phase difference for destructive interference. So this is the first wave as shown. Let us name some points A, B, C, D, E as usual. Now the phase difference between O and the point A is a pi. Then for B it is a 2 pi. For C it is a 3 pi. For D it is a 4 pi. And for E it is a 5 pi. Now let us analyze the same diagram thrice from point of view of the interference. Interference study करण्यासाठी आपल्याला एकच डायग्राम इथे 3 वेळा काढायचे. ओके, आणि यानंतर मग आपली एंट्री होणार आहे सेकंड वेव्हची. आता सेकंड वेव्ह आली, पण आपण काय स्टडी करणार आहे आता इथे डिस्ट्रक्टिव्ह इंटरफेरन्स. वी आर गोइंग टू स्टडी द डिस्ट्रक्टिव्ह इंटरफेरन्स. So second wave is arrived here or emerges such that or incident such that it starts from the point A and the crest matches with the trough. Now what you observe here is that the first wave, that is blue wave, and this red wave, that is second wave, there is a phase difference, say pi. So there is a phase difference pi. Okay. So here the crest coincides with the trough. The phase difference is pi. So destructive interference takes place. Now second wave starts from point C. Again crest matches with the trough. So there is a destructive interference, but the phase difference is 3 pi. Now crest coincides with the trough, and also there is a destructive interference. Now this is the third case when the second wave starts from the point E, and the phase difference is how much? 5 pi. 5 pi. So again crest matches with the trough, there is a destructive interference. Okay. Now what is the conclusion here? In case 1, the phase difference is 1 into pi. In the second case, the phase difference is 3 into pi. And in the third case, the phase difference is 5 into pi. So what we observe here, this is 1, 3, 5. These are the odd multiples. These are the odd multiples. So what we observe is here is that for destructive interference, the phase difference must be odd integral multiple of pi. Yes. When phase difference is what? How to indicate the odd number? It is 2m minus 1 into pi, and value of m may be 1, 2, 3, 4, and so on. So there is a destructive interference. Destructive interference होण्यासाठी phase difference हा odd integral multiple of pi आला पाहिजे. After this, we will learn about the constructive and destructive interference pattern, or we will learn about the interference of the light. Okay. So what interference of light? There is either constructive interference or either destructive interference. When there is a constructive interference, what we observe is a bright band. When there is a destructive interference, we will observe the dark band. Okay. But we will learn the constructive interference pattern and destructive interference pattern in detail in the next lecture.